Hey everybody, we are back at it, this time with cylinders. So I'm going to start by talking about the formula sheet and then we will get into some examples. So in Virginia, this is how the formula sheet looks. We're given three formulas, two for volume, which we've talked about before. Volume is the inside of a shape. And then we are given one formula for surface area, which is the outside of a shape. If you are familiar with any of the other 3D or even two-dimensional shapes, you probably know the next two letters. On a circle, R means radius. And if you look on the picture from the formula sheet, they actually label the radius for you, just in case you forget. And then H pretty much always means height. I can't think of a time that it doesn't. And then, if you watched the video on rectangular prisms or pyramids, we talked about this capital B. But in case you don't know, the big B means the area of the base. And I mentioned in the rectangular prism video that Miss Voss and I usually just like to use the first volume formula, but I can see why the second one would be helpful. So let's make sure we understand it. The base of a cylinder is a circle, and the formula for the area of a circle is pi r squared. And if you look at these two volume formulas, basically they took out the pi r squared and just replaced it with a capital B. So it's calculating the same thing, it's just written a little bit differently. And if you decide that you like the second one more than the first one and you are good at using it, more power to you. I think it really helps understand what volume means, but sometimes it can be a little tricky to remember what big B is. So that one is kind of up to you. Let's stop and think for a second of an example of a cylinder. Try to think of something maybe around your house or something that you've seen at school that is a cylinder. And then think about on your object, what would be the volume and what would be the surface area? So my example is going to be a soda can. I think this is a cylinder that most of us have seen before. It's not a perfect cylinder, but we're going with it, okay? So since the volume is the inside of the shape, the soda is going to be the volume, right? The soda and the bubbles that are in there, that's going to be my volume. And then the surface area is going to be the metal that makes up the outside of the can. I think it's aluminum, but aluminum is a lot longer to spell than the word metal. So if you can think of a real life example that might help you with some of your problems as you go, and before we dive into actually using this formula, let's just remind ourselves how to look at a circle, first of all, because every cylinder has two circles, and if we don't know how to attack a circle, we can't attack a cylinder. So the diameter is the distance all the way across the middle of a circle, in this case, 11 centimeters. And the radius is the distance halfway across. So that would be whatever 11 divided by 2 is, which I can tell you is 5.5 centimeters. You also have to be able to find the area of a circle. If you can't find the area of a circle, gonna have some trouble with a cylinder. So I will remind you that the area of a circle formula is pi r squared. And we can make Desmos do this work for us, fortunately, because we already know that our radius is 5.5, so we can figure out that the area of this circle is 95 centimeters squared. If you can deal with a circle, you are going to be fine with cylinders. Let me just tell you that. We're going to do three examples where we either have to find surface area or volume, but I'm going to type all of the formulas in while y'all are paused, and I'll be right back. Okay, ta-da! Got them all in. So I put in both formulas for volume because we're going to end up comparing those while we're doing these problems. And then I put in the one formula for surface area. You'll notice that I only typed S instead of SA because Desmos does not like having those two capital letters next to each other. So here's my formulas. My first question says, find the surface area of the cylinder. So if I am looking at the formula for surface area, I see that I need to know a radius and I need to know a height. So I'm going to write those two things down in my notes and then I'm going to see if I can figure them out from my picture. So my height, hopefully you can tell, is 5. It connects to both of the bases with a right angle, just like it does in other shapes. But I don't have a radius. And that's because my diameter is 9. So my radius is going to be whatever 9 divided by 2 is. And I'm not even going to bother to figure that out right now because Desmos is going to do that for me. So when I come over here to Desmos, I'm just going to put in my radius and my height, and I'm going to let Desmos do my work for me. 9 divided by 2 and 5. And then up here, I can see my answer. My surface area equals 268.6 centimeters squared. Now, for my next example, this one, we're going to find the volume 2 different ways. So I'm going to go ahead and delete my surface area problem or formula just for now because we already got a lot going on. But I do have both of those formulas already typed in. Now, the one on the left, I need to know the radius and the height. The one on the right, I need to know the area of the base and the height. Okay, so this cylinder has actually been tipped over onto its side. The height connects the two bases, and it actually does form a right angle with both of those bases, but it connects those two circles. So my height for both of these is 8. Okay, then to find my radius, luckily, they already gave it to me. That's halfway across the circle. So my radius is 3, which means I can already use the formula on the left because I know the radius and the height. The radius is 3, the height is 8. I get 226.2 feet cubed because volume is always cubed. But I don't have an answer for the formula on the right yet. I know that big B is the area of the base. And I know that the base is a circle. So if you go back to the beginning of the notes, we wrote down what the formula for the area of the base was. Pi r squared. So the area of the base is going to be pi r squared. And if you're thinking, oh man, that just seems like a whole extra step, I don't want to do it that way, you don't have to. But to somebody, that may make more sense. So I'm going to put that this is pi r squared. And Desmos already knows that the radius was 3. So it can give me my answer now. So if you look at this first volume, which was the formula on the left, and you look at this second volume, which was the formula on the right, it gives me the same answer. You are probably going to have a favorite method, and that's fine, but you've got to decide which one you want to do. Okay, so we've done surface area, we've done volume 2 different ways. Let's see what this last one is. We should be a pro by now. The last one says, Natasha bought a gallon of paint in a cylindrical can. The can is 18 inches tall, and I'm noticing, you can't even see it, I'm noticing that that's not labeled in the picture, so I'm going to label 18 on the side. And it has a radius of 6 inches, so I'm going to label my radius 6. How much paint does it hold? So if I'm talking about how much will go inside of it, that's volume. And I'm going to use these two formulas again. Okay, so I know that the radius is 6. I know that the height is 18. I still have what big B means. So both of my formulas give me the same answer. 2035.8 inches cubed. Okay, and that's pretty much all that there is for cylinders. Decide which formula works for you, and you should be good to go. See you next time.